Okay, so I want to just spend a little bit more time on this Definitive Technologies SuperCube Trinity. I just want to check the power supply voltages and make sure I didn't do anything wrong. So I've got the schematic printed out for the low level power supply, which I have sitting up right here. And the first thing I want to do is, you can see I've got all these caps marked. This is the bottom view. This is as you're looking at the board right here. So I want to check C8, but C8 is not really connected to anything, so I can't at this moment. This is C18, and as you can see, the positive of C18 is connected to ground, and I do have a ground lead attached to one of the input jacks right here. And so C18 is the second of these three caps. So I just want to make sure I can get that to stay on there. And I do have 0 ohms to ground on that one, so that is good. C19, which is, gotta find my bearings here. 1, 2, so that's C19. And just want to make sure that the negative is grounded on that one. And it is perfect. C32 kind of floats right here. It's not connected to ground. This is ground, so C33, the negative should be grounded. And that should be this cap right here. Negative is on the right side. And that is grounded. And then C16, the positive should be attached to ground right there. And C16 is this one right there. If I can get it to stay, yes, the positive is grounded. C17, yeah, positive connected to ground. And so that is that one. So this is the positive connected to ground. We are good there. So let's go to volts. I don't have the power amp connected, but I should get voltages once I apply power to the preamp or the low level board. If you saw my last video, I did post all of these diagrams at the end of the video. Hopefully they are clear enough that you can read them and understand them. So C18 on the negative, I want to see a negative 32 volts. That's the second capacitor up. 1, 2, negative is on that side. And I only have 1 volt. Huh. Okay. Well, that could be a problem. So I don't know if you can see this, but it goes through a coupling capacitor and then through a single diode to ground to keep the charge constant, and then a reverse polarity diode to create a negative voltage on this side. That comes from AC 32 volts number 1, and it's kind of in the way, but there's AC 32 volt 1. There's AC 32 volt 2. So it's got this little standby transformer right here. Let's go ahead and just measure the voltage if I can get my test lead back out here. So we'll go to AC. And we'll just go across this guy. And we do have 27 volts. Huh. That's kind of interesting. Do we have the positive 32? Let me go ahead and reconnect the voltmeter. We'll put it on DC volts and we'll measure C20, which is the third of the large capacitors. 1, 2, 3. And positive is this side. And we have 67 volts there. That's only a 50 volt cap. WTF? Why do I have 67 volts there? And my input voltage is currently only about 115 volts. I'm definitely not overdriving this thing. What is going on with this negative 32 volt supply? C18. Am I hallucinating? So there is the negative side. 1.029 volts. 1.028. Is it dropping? 1.0. Yeah, it is dropping. That's the ground side. Where does that go? Like I said, I do not have the power amp connected at this moment. I've just got, it's just the, what they call the low level board or the preamp. Okay, I'm going to have to troubleshoot that out. That might be part of our problem. Hello? We should be getting our negative 32 volts, I do believe, even with the power amplifier disconnected on here. Yeah, 1.011, it's dropping. Something's going on here. Okay, well, I'm going to kill the voltage because I don't need to kill this C20. See what it's got now. It's down to 22 volts. I don't think I need to have the power amp connected at this moment to measure these voltages. Just for the heck of it, we'll do a quick measurement on the positive. Whoops, sorry. Move this back over, you guys can see it. We'll do a quick measurement on the positive 15 and the negative 15 and just make sure that we have those. So negative 15 is going to be the negative side of C16. So I'm just going to power it on briefly. And I do not get that. What about the positive 15 side on C33, which is going to be that lead right there? What? All right, something is just not right here. Maybe I've got to have the rest of the board connected. All right, well, let's try that. Let's plug it in. I don't think I need to, but we'll try it nevertheless. Okay, I have the amplifier board connected. I did not connect the AC portion of it, just the low voltage portion. And I'm thinking when I was looking at the schematic, there are two ground leads that short together, so it may have an open ground if it's not connected. So let's go to C18 right here and we'll look at the positive side of it. And so that is the third large capacitor. Power this on. And I'm still seeing 60 volts there. That shouldn't be. Oh, whoops, sorry. Well, that was the right one. Third one up. So C18, once again, we'll look at the negative side of C18 and we'll see if we get, and we have 0.92 volts. Okay. There's a problem right here. That might be the whole issue. Just in case, I do not have speakers connected, but the main amp is connected at this point. And I just want to see if I power this on briefly, do I get my negative 32 volts right here on the negative side of C18. So that one's 8, that one is 18, that is the negative side right there. And I do not. So either we've got a bad diode. I don't think we have a bad coupling cap. I'm going to go ahead and disconnect all this stuff now. And we'll set the amplifier board aside for now. So let me dig this schematic back out so you can see it just a little bit better. So just for the heck of it, let's go to AC volts and look at the positive side on the C8 capacitor, which is the very bottom one right here. And just see, do we get an AC voltage on this thing when we power this up? We did, but it's dying down. Do I have an open trace? Let's see what we get on this side. Same thing. So I am connected to ground right here. And we're taking this off of AC32V1, which is this side. Do I have a bad bridge rectifier? Huh. All right, where is the bridge? There it is. So I think that's going to be negative or not. Oops, sorry. I should have been on diode, doggone it. That should be AC input. Okay. Good junction, good junction. Good junction. And good junction. Might be kind of hard to see, but I have 542, 543. Then if I reverse the leads, 540 and 539. Okay, all that's good. What am I missing? What am I missing? I think something's loading down this circuit, causing an imbalance, which is why this cap has like 60 volts on it and this cap has like 1 when it should be 32 and 32. Well, let's do an ohm check across C18 and just see what we have. And we're not shorted, that's for sure. No, we have no shorts on the negative 32. That's what we're lacking, is the negative 32 volt supply. So I wonder where's this? So we have positive 12. And how does that work? To positive 15? And then negative 32 to negative 15. I think this is a misprint. I think this should be positive 32, regulating down to positive 15, and then negative 32, regulating down to negative 15. What about C16? That is the negative 15 volt output. And so that's that cap right there. What do we have across it? $66 ohms. Both ways. That seems a bit low to me. I don't think we should have 66 ohms right there. Okay. I am going to warm up the solder sucker and pull that cap out. Maybe it's just a bad cap. Wouldn't that be something if that was the whole problem? One moment, please, once again. Nope. Nope, that cap is good. Not shorted. So do we still get 66 ohms? That seems awfully low to me for a 15 volt circuit. There should be nothing on this board that has that low of a resistance, 66 ohms. Huh. Okay, so I printed out a bunch of schematics on this unit, and I'm looking for U4, which has a negative 15 volt supply, U5, which takes the negative 15 volt supply, U6, and I label that -1, U8, they all take the negative 15 volt supply. So there's U6-2, that's the other two halves of the LM324, I believe that is. Yes, LM324. They both take the negative 15 volt. U9-2, they both take the negative 15 volts. And nope, that one only goes to ground. I labeled those by mistake. They all have ground instead of negative. U2, not the group, takes the negative 15 volts in 3 places right there. And we have U5 over here, which takes the negative 15 volts on pin 11. So these are all LM324 op amps, operational amplifiers, LM324. So I'm just going to go ahead and unsolder pin 11 from all of these various op amps. Pin 11, pin 11. With exception of U8, which is a TLO82, which receives its negative on pin 4. Let's start with that one first. That's the oddball, U8 pin 4. All right, let's try to clean this mess up just a little tiny bit. Get the wood blocks out of here. And then see if we can find, there is U4 right there. No, it's on manual really right now. Come on, focus. Okay, there it is, U4. And I want to unsolder pin 4 from that chip. So the pin with the square is pin 1. So 1, 2, 3, 4. It's that pin. Hopefully I can get this whole thing unsoldered. 1, 2, 3, 4. It's that one right there. Wood block coming in again. So there is pin 4. Heated up good. And so that pin should, theoretically, be unsoldered from the top and the bottom if everything goes according to plan. So I'm going to get the ohm meter. We'll connect the negative. Actually, I have the positive connected. I'm connecting the negative to one of the RCA jacks. And let me zoom out just a little tiny bit. And then hopefully you can see the ohm meter right there. So I just want to measure this pad. And we are not shorted. Wait a minute, 495 ohms now. 1, 2, 3, 4. What the fork? Make sure we have, yeah, we got good ground. And so that was going to be C16, which is this cap right there, ground, and 69 ohms. Why am I not getting my negative 15 volts on pin 4? 1, 2, 3, 4. Oh, great. Is that a misprint? This thing just keeps getting longer and longer. Holy crap. Well, we know it's not U4, pin 4. Did I just read that wrong? No, I got the right pin unsoldered. I can see solder around it. And that is definitely U4. Hang on. That's my bad. It's U4 pin 6. I unsoldered pin 4 by mistake. Whoops, I saw that 4. I thought that was it. Okay, pin 6. Alright. Let's lay this back up here. And we'll go ahead and resolder pin 4. Yeah, I'm using the solder sucker as a soldering iron. 1, 2, 3, 4, 5, 6. Oh, look at that. Add fresh solder to it. Heat it up for a moment. Okay. Can you see the voltmeter? Nope. I got it tipped up. Doggone it. Why is this so freaking hard? Okay. So you can see pin 6 is still 70 ohms. And I'm going to say that I thought I was going to say the pin is good. So I'm going to go ahead and move this pin. I'm going to say that's probably not it. I'd like to get the pin isolated like that. So I get 70 ohms on the pad. Yeah, it may not be unsoldered completely. That's weird. Maybe it gets it in 2 places. The gift that keeps on giving. Yeah, I don't think it's unsoldered completely. Let's add some fresh solder to it and try to unsolder it once again. Sometimes that's what it takes, especially if they use lead-free. Have to flood this with regular leaded solder because it has a much lower melting point. And we'll see if that makes any difference. 69 ohms. I don't want to have to pull the whole freaking chip out of there. Come on. Let's try to wiggle it, see if we can break it free. Okay, open. Hopefully you could see that. Yeah, I'm going to say that's not it. There, I'm touching, well, shoot. Okay, there I'm making contact and we're open. So that is not it. Definitively on the definitive SuperCube. Okay, so we ruled that chip out. Let's go ahead and resolder it. Well, this video is going to be long, long, long. Okay, so definitively we know it is not going to be U4. So let's look for U5, pin 11. Oh, cat, come on. No, you cannot be up here right now. Okay, there's U5 right in the center. Pin 1 is right there. And what I say? No, no, I do not want you up here right now. Pin 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. I don't want you back there either. I'm just going to add more solder and resolder it a second time, or unsolder it a second time, just to get a good flow. Make sure it's good and hot. Okay. And we'll check that again. So just for the heck of it, let's just go over to here. We still have 70 ohms. Move that pin around. And yes, it is unsoldered. Well, no, shoot, still says 70 ohms. Must be touching the pad. No, I'm going to say that's not it. Although I don't think it's unsoldered completely. Oh, this thing's going to last forever. All right, I'm going to pause this. It's taking way too long. Okay, well, I ended up pulling every IC off this board that used the negative 15 volt power supply, and I still had 70 ohms to ground. So what I found was this U1 regulator IC right here. Had the freaking conductive glue around it, and you can see the earth trace, or the ground trace, is this like checkerboard pattern right here. And so I dug off all the conductive glue. There's still a bit left right there. And this thing was like covered in conductive glue. Why are these companies still using conductive glue this many years later? Anyhow, I dug that off and the 70 ohm short went away. But I only had about 17 volts on my negative 32 volt source. So I went ahead and I pulled that capacitor out, because this diode right there, the second one on the right, this is the negative 32 volt source. And as you can see, it runs underneath right here, and it goes down to there. And then, where's that trace? It's gone. It's nowhere to be found. And I have all the old capacitors. I need to pull them out and see if it got lifted up when I unsoldered these capacitors. Maybe that was my fault. I think there might have been corrosion on one of these. You can kind of see the gunk build up here. I did not wash this board in the dishwasher, which I probably should have done. And probably going forward, I will wash all these boards in the dishwasher. So I had 17 volts of negative DC voltage, but I had 11 volts of ripple. AC ripple on that capacitor, or on that diode right there, the anode of this diode. So I think I'm just going to go ahead and run a jumper from the anode of this diode to the negative lead of this capacitor. And I'm betting that's going to resolve the issue. And I'm hoping this thing will run perfectly after that. Of course, I don't know. We'll find out. So I went ahead and I ran a piece of 26 gauge enameled wire to that capacitor from the anode of that diode right there. And in case you're curious, it is come on, focus. It is off the board, so it is suspended. And I might put a drop of RTV on that. I'm not quite sure yet. But let's go ahead and get this thing zoomed back out where you can actually see what might be going on. We'll move this up over to there. We'll put the voltmeter there. The negative lead is, well, it was connected, but it fell off. Connected to one of the input jacks right there. You might have seen me put it on right there. Block of wood. You can see the voltmeter. I'm going to reset it so it doesn't die. And so what I'm looking for right here is about negative, well, it says 32 volts. Power on. I've got negative 34 volts. And so if we go to pin 11, so that is 7, 8, 9, 10, 11 of these ICs, and look at that, I've got negative 15 volts, well, 14.93. That's what I wanted to see. Here is the regulator right there, 1366, that's probably the adjustment pin. And 1495 is the output, this should be the input, and I've got negative 35 volts. So absolutely perfect. Let's look at AC voltage. See how much ripple we have. And we have 0.12 volts of AC ripple, which I'm perfectly fine with on a 32 volt power supply. Sorry about that. All right, let's hook up the rest of the unit and see if it makes beautiful music. Okay, I do have my MP3 player connected. I do not have the volume turned up. It's the knob right here. It's turned down all the way. I just want to power this thing on with the amp connected, looking at the power consumption, and see if the power amp turns on and we don't have excessive current at this point. So I'm going to turn the voltage down to about 110 volts. I do not have speakers connected. It normally takes about 30 seconds for these things to recognize audio and finally turn on from a dead start, from an AC power off condition. And I just heard it power up, and we are drawing good current. I'm not too terribly concerned about that. We're probably drawing about 20 watts right now. So let's go ahead and get the speakers connected. So this is the positive lead. Hopefully I don't short anything out. There's the negative lead. Oh, and I don't have any hum this time. That is excellent. There's the volume. Wow. Okay, this thing is kicking. Remember, I have this into a 16 ohm dummy load at this point. And we're definitely pushing this thing into the point of clipping. Now, keep in mind, I only have the voltage down at about 105 volts right now. And so I'm going to crank it up to about 125. That should eliminate a lot of the clipping issues. Turning the volume up. Oh, went into shutdown over current. So if it goes into shutdown, it won't come out until you turn the volume down. But I'm pretty happy with this right now. At least I know the output stage is good. That was my main concern. After a complete recap of this board, it ended up being that capacitor right there was missing a trace on the board. Oh my God, what a long road. So I'm gonna let this thing sit here and cook for probably an hour or two. Just make sure it works perfectly before I ship this thing back to my customer. I think is in Illinois, I'm not quite sure, but it's been here for a little over a year right now, just because of so much that's been going on. 6 months at least behind because of my daughter's accident. And I'm starting to come around, a little less depression, which is a good thing. But yeah, working good, trying to get back into the swing of things. Just, it's taken a toll on our family, but she is definitely doing much, much better at this point. Anyhow, that's it. It is actually working. I love it. So like I said, gonna let it cook for probably an hour or so. Just sit here and run, get some heat in it. And this thing has been like definitely weighing on my mind for so long. So I'm gonna go ahead and post the video I shot of replacing the FETs. I'm not sure how complete that is. I might have lost a segment or two. And then I'm gonna go ahead and post the video I shot yesterday when this thing went into shutdown, and it would not come out of shutdown because of that freaking conductive glue on that little regulator IC that you see right there and the missing trace. So check your power supply voltages. Check them, check them, check them. That's all I can say. Let's see. That's not it. I've been marking off the chips as I check them. And like I said, if you go to the last video, you will actually see, where the freak is the schematic? There it is. So on the schematic right here, whoa, it's going into clipping, so that thing is working. You see the lights flashing. So what was going on is between the anode of D2 right here and that capacitor, actually I think the anode was connected to the source ultimately, but that capacitor was not connected, and that was causing the issue, as well as conductive glue shorting this chip to ground right there. Anyhow, working perfectly. Hopefully it keeps working perfectly. If you do need a schematic on a Definitive Technologies SuperCube 1, 2, 3 reference or the Trinity, check my last video. I did upload 5 seconds of each page basically, so you can kind of scroll through that at the end of the video. So I'm gonna pause this, let this thing run for a while, build up some heat, cycle it on and off a few times, and hopefully get ready to ship this thing back to my customer. Okay, well that's a cat. So let's take a look at this SuperCube Trinity right now that I have sitting over here running. And yeah, a little bit warm, 180 degrees. Pushing this thing a little bit hard. And those two resistors down there, almost 200 degrees. There's the preamp stage, 130 degrees. And then here is the dummy load, 108. I don't believe that for a second. Looking down inside the dummy load, yeah, there's the big loads, 260, and oh, that thing turned sideways, sorry. 260, 230. Yeah, definitely putting out some power on this thing. Here's the variac over here. Not too terribly warm. I don't have this thing actually pushing. There's a solder station, and There is the monitor I use, and then of course the camera's hot because I'm filming right now. But anyhow, pretty happy with the results. Yes, I believe I have a solid fix. Look at that thermistor, 134 degrees. That's like to quench the inrush on this unit when it powers up. I believe it is an NTC, negative temperature coefficient. Okay, well, it flipped over on me. There we go. And the FETs actually look fairly cool. Those are the 4 FETs that you see right there. Flip it back over. There we go. Yeah, very happy on this one. Very, very happy. Got this thing running. The customer should be so happy. Hopefully he's not too terribly upset because it took a long time. Just so much going on. Once again, I really apologize for all the personal issues that we had. But once again, it is working. And he even had a bad input jack. Replace that jack on there, so everything's good. I'm not using the LFE input because I don't have a LFE source right now. I'm just using the regular inputs. What is that? That's the regulator, 128, 130 degrees. I'm fine with that. A couple little power transformers over here. And what's the actual temperature of the transformer? Oh, yeah, what, 70 degrees? Yeah, I'm fine with that. There's the other little standby transformer. If I can get onto that one. Can't see the numbers. Hello. 82-ish degrees. Fine with that. Filters, nice and cool. And I did go ahead and put the resistor back in the insulation, and I put a zip tie around it to hold it on there. It seems to be working just fine. I suspect this thing isn't meant for 2,000 watts continuous power. It's meant for 2,000 watts intermittent peak power. As in the last video, I posted IPP-ILS is a power rating that a friend of mine who has passed away many years ago used to use. Instantaneous peak power if lightning strikes. IPP-ILS, if any of you remember the old car stereos they used to sell at these little swap meet places that said like 650 watts, but it had a 2 amp fuse in it. Yeah, that's IPP-ILS, instantaneous peak power if lightning strikes. Okay, well that is going to wrap up this video. I'm very happy with this thing. I'm going to go ahead and get it packaged up and get it ready to ship back to my customer, which I thought was in Illinois. I'm not quite sure, but we'll figure it out. I'll figure it out. Go ahead and leave me a question, a comment, a concern down below, good or bad. I try to respond to the comments when I have time. While you're down there, if you could hit that subscribe button and like this video, it really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter, at NorCal715. You can email me, NorCal715videos@gmail.com. That is the best way to contact me. Please be very, very patient. I've been trying to get so much work done, I have not checked emails in months. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone, thank you for making it to the end of this video. I really, really appreciate it. Everyone, once again, thank you so much for watching. Have a great day. Bye-bye. Okay, I finally have your SuperCube Trinity up and running. So you'll have to watch the videos. I have like 3 of them on this thing that I haven't posted yet. But I found a corroded trace, ran a jumper wire right there to correct the issue, and did get a complete cap replacement, which you will see on the videos. So you hear it running in the background. That is actually going into a dummy load, which is only supplying about maybe 1/100th of the power to the speakers. So I can actually run these things under a full load without blowing up my little tiny speakers over here. Anyhow, it's running. It's been running about 45 minutes right now. I'm going to let this thing run for probably 2 or 3 hours before I get ready to box it up and get it ready to ship back to you. But I'm watching the current over here on my Variac, and it is pulling some heavy current. Not 2,000 watts, but probably pulling 500 watts of power. Anyhow, I definitely do appreciate your patience on this unit. I realize it has been a very long time. Partially my fault because I had some personal issues going on, but this one has been weighing heavily on my mind, and I just wanted to get it up and running once again. Anyhow, there it is. Your SuperCube Trinity subwoofer back running once again. Flawless at this point. I love it. By the way, thank you so much for getting the schematics from the manufacturer. I would not have been able to repair this without the schematics that you obtained from the manufacturer. There's no way I could have figured this out without it. Anyhow, there's all the work that I've done in the testing on the different IC chips, capacitors and whatnot. And what I found was this capacitor had a broken trace, probably from corrosion or whatnot, on the circuit board. So anyhow, that is C18 was not connected. And then I also found a bunch of conductive glue around this regulator IC, which was pulling the voltage down. Anyhow, thank you so much for being very patient with me. I really, really appreciate it. Okay, we'll get this thing boxed up and ready to ship back in the next few days. Thank you once again for being so patient. Bye-bye.